Alright, so here is our 3.2 assignment, and this is part 2 where we're going to do the last 2 problems because we ran out of time on our 30-minute limit here. So 3.1 questions, which is just reviewing the previous in this lesson, says that for these 2 exercises that we're going to do, we need to graph the function and analyze it for domain, range, continuity, so hopefully you remember back to analyzing things. So first thing we're going to want to do is graph this function. Alright, so taking a look at our function here, we do have our initial at 0, 3 because of that value of the a. And then from there, the 2 kind of tells us the rate of what's going on. So from 3 it'll go to 6, and then from 6 it'll go to 12, which doesn't really exist. And then, of course, it's going to asymptote at 0. That was a really bad line. Oh, that's even worse. Okay. There we go, and then we have our asymptote at y equals 0. Oops. Alright, so checking out our domain is going to be the x values, and you can see it goes to negative infinity and just slowly, but to positive infinity for your x's as well. So we'll go with all real numbers. Then we have our range, and our range is restricted at 0, but then does go up to infinity. So 0 to infinity is where our y's are located. And then continuity is asking, is it continuous or not? And so it is continuous. Then where is it increasing and decreasing? And it turns out it's increasing always. So no matter where you are, the next point next to it is going to be in an increasing way. Then we have symmetry, and so symmetry would mean if it's odd or even, and this one is none, so it is not symmetric anywhere. It's bounded below at that y equals 0 horizontal asymptote. Its extrema do not exist, because that would mean it has a local minimum or maximum, which it doesn't. And then its asymptotes is that there is a horizontal asymptote at y equals 0, no other asymptotes. And then the end behavior means that our limit as x goes to negative infinity of the function, and our limit as x goes to positive infinity of the function is going to be at, so this is to the left here, is 0, and to the right it's infinity. So again, this is saying as the x's go left, the y's go to 0. Right? Left, 0. And as the x's go to the right, the y's go to infinity. Alright, and then your last analyzing is of a logistics function. So when you type this into your calculator, definitely want to make sure you have parentheses around your denominator, or depending on what calculator you have, it kind of puts it in actual fraction, like little notation. So we'll type that in. And so as you can see, the 5 is the highest point that it's going to go, and then of course always 0 unless it has some sort of number added or subtracted on the end. And then at 0, it's intersecting at 1, and then it's going to go like that. Alright. So after we look at an image of it, remember that we are going to talk about the domain and range and continuity. So the domain is all real numbers going all the way left and all the way right. The range, however, of course, is restricted between 0 and that upper limit of 5. And then the continuity is, yes, it's continuous. When you're drawing it from left to right, there's no need to pick up your pencil. The next thing they'll talk about is increasing and decreasing and symmetry. And increasing is actually always and not decreasing. Again, as you trace the line, you're never actually going down ever. It's always ever so slightly up. The symmetry, I mean, technically there's going to be kind of a point halfway between here, but that would rotate more or less as long as it grows, but I don't think it does. So we're just going to say none, because technically when they're asking symmetry, they're really just asking, is it an axis or the origin? And it's neither of those at this point. We can get more specific, but we don't need to. Let's see. The next question was boundedness. And for this one, we get to say bounded, meaning above and below. And then they ask about extrema, and there are none of those, because it doesn't even really have a sort of local maximum, because it just always goes up. So anyway, then they want to know about the asymptotes. And so we have two horizontal asymptotes, one at y equals 0 and one at y equals 5. And then the last piece is your end behavior. And so we're going to look to the left and to the right, meaning the limit as x goes to negative infinity of the function, and the limit as x goes to infinity of the function. And so as it goes to the left, it's going to go to 0, and as it goes to the right, it ends at 5. Alright, so that is the rest of that assignment.